Good afternoon. I'm here today to talk to you about passive design and building technology. Do you ever wonder how much money you waste? Do you ever wonder how much money your house wastes? I can tell you, it's a lot. I currently live in a 1960s house and it seems like a sieve. And every day I think about ways to upgrade my house and how I can incorporate passive design and technologies to increase my health and livability aspects of my home. So I am a Red Seal carpenter. I am a certified passive house tradesperson. And that picture of me you see up here is with my coworker Nick. We were actually fortunate enough to go to Germany a couple of years ago for a 2-week kind of passive house conference tour. And we were taken by Innotech Windows, which is one of our vinyl window manufacturers that we use. And yeah, we were very fortunate to go on that, and I learned a lot, and continuing the passive house crusade right now. So today I'm going to talk to you just as a general overview of passive house design and building technologies, where they're located in your house, what they can do for you, how you can incorporate them, and why you should incorporate them. I'll follow up with a brief summary and conclusion, followed by a page of references and question period for you. So general overview, in BC and Vancouver, we use the STEP code, which is increasing the efficiency standards in multi-unit construction. It's being ramped up, I believe, every 5 years to get us to a higher standard of energy efficient buildings. Below you'll see there's the LEED certified program. I've worked for my company for the last 10 years, and every building that we have built has had some sort of LEED certification. So I've been fortunate enough to work fairly closely with these with LEED and with their certification program. My last project was a LEED Gold project, and the project before that was LEED Gold, but we were actually able to achieve LEED Platinum with all the points that we collected. So I was particularly happy about that achievement, and also I will be referencing some of the design aspects of that project in this presentation. So when I talk about buildings in general and passive design, I usually reference the human body because I believe that everyone can relate to that. So I will do the same today. I'm going to talk to you about 7 different design concepts about passive technology. The first one will be skeletal and muscular, which will fall under the framing category. Number 2 will be the circulatory, which will be the mechanical category. The nervous system will follow under the electrical category, and same with the sensory. Respiratory is going to, again, fall under the mechanical for HVAC and HRVs. And digestive is going to be, again, mechanical for heat, water, waste recovery. Wall framing. So on the Crest, which is the project that got LEED Platinum, we were able to utilize 2 outside walls on the project. One was filled with spray foam, the other one was rigid insulation. So these 2 insulations kind of worked well together. Spray foam is highly flammable, and rock wool is more or less flame retardant, so that's why they were both used in conjunction with each other. The outside wall gained some rigidity and by using the spray foam, and it was actually great because it came out and around the stud and completely encapsulated it, so it added to the total isolation between exterior wall and interior exterior wall. So the second part to skeletal and muscular is the open web top hung trusses that we use. You can also use them as joists, but for the spans that we were using, they were They were trusses, so they're slightly bigger. So the benefits of them being top hung was that there's minimal thermal bridging at the outside of the building, and we were able to uh, put them on the inside interior exterior wall. So again, that surface area of the end of the top cord was unable to even make it to the outside, so it was not able to draw in any cold air. So when it's top hung, it adds to the air sealing detail as well. You're able to slide drywall right up to the underside of the slab above and just do a slight notch around the top cord. So it's a nice, quick, slick detail. So with it being fire rated, it also adds to the air sealing and the compartmentalization of the individual unit. The benefits of being open web is there's the elimination of unnecessary bulkheads. By that I mean usually when you use joists you have to go forward, back, left, and right, but you usually run into a joist where you have to jump down, as I say, and run across underneath and creating unnecessary, unsightly bulkheads. So then again, it adds for an easier rough-in installation, and you're able to add sprinklers, which means that you don't have to do any intricate fire chases within the joists. Now that it's open web, you can put a sprinkler up there and it just sprays the entire ceiling cavity. So 2 is circulatory. So I'd be talking about using tankless hot water heaters. So the pros to a tankless hot water heater is that there's no holding tank, and it takes up less space in your house. There's a never-ending supply of hot water. So once you get past the initial 5-second delay, you can keep that tap on and you'll have endless hot water, as opposed to a tanked hot water heater that we're all used to. It will run out. It won't be able to keep up fast enough. It's more efficient than our typical high efficiency tanked hot water heaters because you only use as much gas as you need it when that tap turns on. The cons, yes, you have to wait an additional 5 seconds to get heat, but I think you'll adjust to that. And it wastes slightly more water because you're waiting for that hot water to come through the lines and make its way to you. Number 3 is nervous system. So I compare that to using smart technology and apps and also appliances within your home. So all of these 6 you are able to get access to on your phone at any point in time, and you can adjust them. You can turn things off and on. So again, number 1, thermostats, probably the most important one. That'll be able to help you cut your heating and cooling costs by 10 to 15%. Light bulbs, they're dimmable. Wall plugs, again, if you are having issues with your kids watching TV till 2 in the morning, you got one of those plugs and you can put a parental control on it. Appliances, they actually are so smart that they will let you know when you need to do some preventative maintenance so that you don't need to throw the appliance out. Again, adding to our overly wasteful atmosphere that we live in right now. Irrigation, so you can adjust it, but also you're able to have your app adjusted according to the weather forecast so that you don't water when it's already raining outside or vice versa. And then finally, security. Having a smart home and having security integrated will allow you to see if there's truly an intruder or if there isn't, and call 911 accordingly and not waste anyone's time and put anyone in danger if you don't need to. So number 4 would be sensory. For sensory, I think of hearing and sight, and when I think of that, I think of windows. So for passive technology, I think of high efficiency vinyl windows. So they'll have vinyl frame as opposed to aluminum. There'll be 2 or more panes of glass. I mean, typically you have 2 or more panes nowadays, but that's just the minimum. Reflective coatings, you'll have a reflective coating on the outside of the glass to again help deter any additional heat and sunlight from coming into the glass, and then between the panes of glass, you'd have it filled with a heavier gas such as argon to help thermally and acoustically isolate outside from inside in your glazed unit. So for respiratory, I'd be thinking about HVAC, ERVs and HRVs. So they're constantly running, so they're constantly providing fresh air to your house. They're increasing the indoor air quality. Their efficiencies are now anywhere between 75 and 95%. HRVs are usually around the 70-75%, and ERVs are 90-95%. The difference is that ERVs actually extract energy from the moisture within the air as well, as opposed to HRVs only extract the heat from the air. The con is that there's lots of maintenance and the parts are expensive. So number 6 is digestive, and the final one, and it is going to be about, so this is the water heat recovery system, and the way it works is that your supply line or your recirculation line for your tankless hot water would run through here, and any sinks or showers would drain through these main rainwater leaders or wastewater drains with this section incorporated into it. And as the hot water drained, it would be picked up by the fresh supply line, and the heat would be extracted from the wastewater and pre-primed prior to going into your tankless hot water heater, making it that much more efficient. So the conclusion is that these are pretty much the 6 key points that you need to incorporate into your home if you're thinking about building passively. Any one of them could be incorporated, but start with one and go from there. So these are my references. And does anyone have any questions for me? So at this point, if you have one question for me, oh, what's that? Oh, what would I use if I had to use anything? Me personally, I would probably choose an ERV. It's probably one of the more expensive things to do, but currently I am having to deal with mold building up on my aluminum windows. So I believe that if there was better, higher efficiency airflow in my house, that ERV would be the best solution for me to use. Anything else? Thank you. Appreciate your time. Hope you learned something. If you have any questions, please get a hold of me at my BCIT email. Thank you.